All right, we're going to look at some double displacement reactions. So across the top, what we have are 6 different aqueous compounds. So these compounds all have cations that tend to precipitate when they're with some certain ions. On the left side here, you can see different compounds of sodium, right? Sodium is a very soluble ion, so no matter what you put it with, it's going to dissolve. And we see carbonate, hydroxide, phosphate, and chloride. And so we're going to see what happens when we mix these anions and get them around these cations. Mostly we're just going to be seeing a lot of precipitates. So these three the solutions across the top have already been added to the well plates. So these are clear. We see some color here, right? The solutions with color tend to have a transition metal. You can see the copper and iron, they are transition metals, but not always, because silver is also transition metal, but no color. All right, I'm going to go straight across, and we're going to see what precipitates there are. Here is sodium carbonate, right? It's aqueous. You can see through it. It just looks like water. All right, here we go. Okay, you can easily see that precipitate. Here's another one. So precipitates, you can't see through them, right? It makes it opaque. All right, so you're seeing these precipitates form. A lot of chemistry. It's really these like white solids. Now, this one's a little bit off-white, but these are just white. All right, there's our sodium carbonate. Let's do sodium hydroxide. Let's go straight across. The iron, both of those, it was like a gel when you started. This one too. Okay, so they all precipitate. Everything precipitated here. I'll do a close-up later. So the point isn't like, the point is to see the precipitates. It's also to say, okay, well, what is that thing? That solid stuff that I see. What's the formula of that? And the formula is going to be the cation up here combined with the anion over here in the right ratio. So now here's sodium phosphate. It's clear. It is silver. I mean, we got this off-white. Now we got a brown. Now we got a yellow. Magnesium's pretty boring. Calcium's pretty boring. Copper, not too exciting. I mean, it's all the same, just different variations of blue. And here's the sodium chloride. This was rock salt, so there's a little bit at the bottom. Maybe I could filter it, but not a big deal. Okay, so for that last row, the only precipitate that formed was this one here with the silver chloride, right? Silver chloride. So chlorides tend to be soluble. There are 3 exceptions, 3 common exceptions that we look at: silver, mercury, and lead. And so you can see the rest stayed as solutions. All right, those are some precipitation reactions. This is what the stuff looks like in a chemical equation, right? You saw what it was. It was just a clear solution. You saw the original solutions. This is what you see on paper. You saw what it looks like with the color and in 3 dimensions. All right, so let me do a little close-up. Okay, so do the silver nitrate. These are the silver precipitates. So at the top again, iron precipitates. That's weird. And no precipitate with the chloride, right? Just clear. Copper precipitates. And no precipitate with the chloride. Magnesium. and no precipitate with the chloride. Last, calcium chloride, of course, is going to have no precipitate with the chloride. If it starts off dissolved, it's going to end up dissolved. So when you are looking at these in the lab, sometimes using the white paper is helpful. Sometimes looking with the black background. Sometimes that's easier. Just kind of do it. Whatever works. Weird stuff. All right. Bye-bye.